Question 13 is similar to the previous questions as well. It's about derivatives of inverse trig functions. Here also we can use the calculator to directly find the answers, or you can use the rules of trigonometric functions, the inverse trigonometric rules and the chain rules, and then we can solve it up. Here to solve using calculator method, you need to know the options. You have to have the options, otherwise it's not possible. And there's one important thing here. Now we are dealing with what? Sine inverse, cos inverse, tan inverse. Whenever it's sine inverse or cosine inverse, remember the domain is within, for differentiability, it's within -1 or 1. It should be like this. Even the same thing for cosine. Whereas for secant x and cosecant x, you need to make sure it is other than these. It can be anywhere from -infinity to -1 and 1 to infinity. And for tan and cotangent, you don't have to worry, any number works. But if there is any undefined values, then it doesn't. So now let's try these. Here, let me type shift dy by dx, sine inverse shift and sine x cubed plus 1. Now you need to close the bracket carefully because this is sine bracket and then this is dy by dx bracket. And what is the value? Let me show you for phi. Will it work? No, it's a math error. Why? Because the domain is beyond this. Now here, what happens if I put, say, 1? Again, it's beyond this. Now let me put anything like 0.5. That's half. Why is this? Because over here we have power 3, right? Plus 1. So you need to take this into consideration. If I put any positive values, no matter what, it's going to go beyond this x value. So when it is not working, it's fine. Just put negative over here. Say you put minus 0.5, you will get an answer. That's it. Why? Because over here, whatever the answer is, must be less than 1, isn't it? How can it be less than 1? If you put 0.5, it's going to be, when you cube it up, it's going to be 0.6 something, 0.6 or something, but it will be minus. So the final answer will be less than 1. That's the concept. Or you can try something like other 0 point, but negative values. It's not going to work with positive because we have cube, and plus 1, it should be less than 1. So try something like this, or you can put it as 0.25. You will get the answer here as well. Okay, choose one answer. I'm just going to choose negative 0.5 here. And it's 1.5549. I'll just write it out because you need to make a habit to write this out. At x is equal to minus 0.5, the value is 1.5491 and it goes on. Now then, you will have 4 options. Imagine these are your 2 options. You need to type them out. I'll type the right side first. 1 divided by 2 times square root, 2 times square root of x multiplied by 1 minus x, close the bracket. What is it? Calculate not at 2, at negative 0.5. And here you're getting a math error. So that can't be the answer. Let's put the correct answer now in over here. It'll be 3x squared divided by square root 1 minus here then x cubed plus 1, close the bracket and square it up. Just typing it out, make sure it's typed properly. And now calculate at minus 0.5, which is already typed. The answer is how much? 1.5491. Yes, that's absolutely the correct answer. No other option can give you the same value. So this is a very easy trick to solve any trigonometric, any derivative, sorry. And over here as well, let's do this one. You need to press shift dy by dx, sine inverse, that is shift and sine, and square root x. Now don't close the bracket inside the square root, go out and close the bracket. Now it's done. What is the x value? Here, remember, it should be less than 1. So what I'll do is I'll take positive 0.5 because I can't take negative 0.5. We got an error, right? Why is that? Because can you have any negative number inside the square root? No. If it's cube, odd numbers, it's fine. But this is root 2. It's even. It's not possible. But this will give me the answer. Positive 0.5. Yes. Let me take even, like, say, 2, 5. Yes, you will get the answer. Okay. But now, I'll consider zero point 0.5. It's an easy number to remember. Let's just put it over here. 1 divided by 2 square root x times 1 minus x. Close the bracket. Now calculate this at zero point 0.5. You must get 1 and you will get 1. And if you calculate at 0.25, it was 1.15 or something. You can see that was the answer. So any unique value of x, you will have one option which matches, and that's your correct answer. Even over here, it's the same thing. Let me do the second one. First, shift dy by dx, shift and cos inverse. 2 divided by x, sorry, it's x, alpha and this symbol. Now go out over there, press next, and now close the bracket. Now here, what can I type? Can I type 1? Then cos inverse of 2, x is beyond the limit. I even can't type 2 because it'll be just 1. It should be less than 1. So see over here, if I press 1, it's math error. Absolutely. For differentiability, even it should be less than that. So no, it doesn't work. So what happens? I can take anything more than 2 here. If x is more than 2, if I take, say, for example, 2.5, it'll be less than 1, right? This number will be less than 1. So I'll take 2.5 here. Say I'm getting 0.5333. So let's look into the answers. And now if I solve this at 2.5, 2 divided by x square root of x squared minus 4. Calculate this at what? I think so. I took 2.5, yes. And it was 0.5333. Yes, that's it. So this is how you can easily solve it up. And now if it's tan inverse, it's very easy. Let me do this, shift and dy by dx, tan inverse, again shift and tan of square root x. Now here, close the bracket. If you don't close it, you will have an error. Now I'll just take any value. I'm just going to take 2. Okay, it's more than 1, but still you will have an answer. Now just put all the options in the calculator and check. It is over here 1 divided by 2 square root x, and open the bracket here. See, it's only square root x. Now it's separate 1 plus x. Now close the bracket. Calculated at 2, I believe. So that's the answer. I can't remember which values I input, so it's very important to type it out. Okay, you have to type it out. That's important thing. Now let's do this anyways. I think so this is correct. I mean, I don't know which x value I forgot because I just blanked out for somehow. Now then, I'll keep this up over here because I need this. Shift tan inverse 1 by x. So I'm just going to take, now this is not going to help. It's dy by dx. Shift dy by dx. That's over here. Now tan inverse of 1 by x. Close the bracket. Now if you're thinking, can I directly substitute over here instead of x? No, you can't. You have to type x as the variable for d by dx. Otherwise, you won't get the answer. Now here I'm just going to take, say, 1. So you will get some answer. Now if you put over here 1, it's directly negative 1 by 2. Why? 1 plus 1 is 2. So you can prove it. Yes, this is the correct answer. All the others will be wrong. So that's how you can check them. Now I'll do this one over here. Shift ln gives you e, but look here, I need to derive this. So shift dy by dx. Now I need to press e to the power tan inverse of 1, of x. And I'll close the bracket over there, then done. Now since it's tan inverse, I can take any value. I'll take 0.605. I'm going to remember this, or you can write it down. Now I'll look into the options. It's 605. So now here it is shift E, tan inverse of x, close the bracket, down we go, 1 plus x squared. Calculated at, okay, 2. That's, yes, it's 0.605. Here we have secant inverse functions. How would you do this? You might be thinking, okay, we know that secant x is equal to 1 by cosine x, right? Because this we know from reciprocal identity from long back. But do you think for inverse, secant inverse x, is it just 1 by cosine x to the power minus 1? Or do you think it's 1 by cos inverse x? If you're thinking any one of this, both are wrong. The actual thing is secant inverse x is equal to cosine inverse x. Not x, it's 1 by x. That's the only thing. Because there's a relationship of this. You do not need to know the entire relationship, but just remember so much 1 by x. This is all that matters. Okay? And you know the range for secant over here. It's any values. Even if you do not need to remember this. If you don't get the answers, just do some trial and error and then you will directly get it, So that's one thing. So now we will solve over here. This one, remember, you need to write cosine inverse of 1 by x to the power 4. This is it. Let's use our calculators and solve them now. I'll do both these problems. The first one is very simple because it's just secant, right? It's shift dy by dx, 4 multiplied by, what is it? 1 by cosine, in this case, x to the power 4, and then you just close the bracket, and then you take any x value here. That should be anything more than 1. So I'll just take x as 2, but I'm getting a syntax error. That means I have not closed the bracket. See, this is the thing. I've not closed this bracket. Now it's all right because this bracket is already opened by d by dx. Now you can see it's negative 40.18 and it's in radian mode. This is very important to be in radian mode at x is equal to, I forgot what x I took, 1.822. So let us just look back to the x. I'm having goldfish memory for somehow now. X is 2. Now then, I need to look into the answers. I need to have the options available. Otherwise, you cannot solve this. So what I'll be doing over here is clearing that off. Type this 16. Now it's all in the numerator. So I'll just write 16 x cubed. Then what do we have? Secant. That is multiplied with 1 by cosine x to the power 4. Close the bracket. Even close the bracket here. Multiplied with tan x power 4. Sorry, it's power 4. And you just close the bracket properly here. And that's it. And calculate it at 2. It must be 40.1822. And that's the answer. Yes, absolutely. Only one will be the correct answer. But we have done secant before. But now let's do the secant inverse, which is more interesting. So here I've written it's yeah, this is the form for secant inverse. For secant, it's just 1 by cosine. Now then, let us type this out. Shift dy by dx. It's 4 multiplied by secant. Now secant inverse is just cosine inverse. That's it. When you have secant inverse, write cosine inverse. But only here the x value, you write 1 divided by whatever the x value here. Now if you're thinking what happens if it's a cosecant inverse, then you have to just have sine inverse 1 by x. Now let's write it out. 1 divided by x to the power 4, and then you have to close this bracket. Only one bracket I have opened for cosine inverse, and that's closed. That's it. Let me take a value of 2. Why? Because it's in the domain 0.5000. Let's try this. I'll write it out over here, 0.5009, and it goes on. Let us try this now. It's 16 divided by x square root, not squaring it, square root x to the power 8 minus 1. Now calculate at what? At 2, because I've taken 2 itself and it's matching. Only one correct option will match. So by this method you can solve any problem, whether it's inverse, non-inverse, anything. Let me do this one here, because left side is pretty straightforward. What about this right side, cosecant? So it's just shift dy by dx. I have to write cosecant, that is shift and sine 1 divided. Okay, I've not pressed shift properly. It's shift and sine. Sine inverse must be there. 1 divided by x. Now close the bracket here. And x value will be equal to what? You can take any, I'll just take it as 2. I'm getting minus. Let me write it over here. Let me clear all this. Minus 0.2886. And then look at the answers. We have to write minus 1. I'm writing minus up, it's fine. Or you can write it outside, that's up to you. x square root x squared minus 1 calculated at 2, and the answer must be the same thing, minus 0.2886, and goes on. This is how we can easily solve all the inverse trigonometric functions. If you have any doubts, please post them in the comments. Just be careful with the radian mode, and when it's secant inverse, it's cosine inverse 1 by x, and when it is cosecant inverse, remember it is sine inverse 1 by x.